divided by area of the basin, divided by the area of the basin. So when the drainage density is 0.0012, if you take that in multiplying the 1000, this will be 12, 13 to 50, 51 to 150, and this is 151. That means higher the drainage density, 0.151, what will happen? Higher the risk of flooding. And lower the drainage density, less will be the risk of flooding. Now someone will say, sir, how this what you are saying is wrong. No, what I said, please understand the definition of drainage density. When this ratio will be more, numerator is less and denominator is more. Numerator is less and denominator is more. What will happen? It will be low values. And when numerator is high and denominator is constant, when you take one low value, you take one high value, then you will understand this thing. And accordingly, the rating is given that drainage density ratio is 0.151. It will lead to high hazard, while the drainage density ratio is 0.012. It will lead to low hazard. Right? Now, it will be very clearly understood from rainfall values. What I am trying to explain about the rating. Right? When there is 1100 mm of rainfall, naturally the probability of hazard is more. So that is one. Right? And when there is a less rainfall, means you go from 1100 to 500, 1, 2, 3, and 4. The rating. Now you understand. I hope you understood what is the significance of rating 1, 2, 3, and 4. At the same time, when we are saying that flood hazard, so you should know that how the factor influences the flood hazard. Right? So how slope influence, how land curve influence, how soil influence, how drainage density influence, how rainfall influence the what you can say flood hazard. If you have considered in your analysis, some of you may be doing this kind of work, and if you have considered this type in analysis, other factors like I was having road and network intersection per numbers per square kilometer, right? So there was one doubt by one student, sir, how the rating is made. If number of roads intersections are more in one particular area, you fix the area, right? What will happen? Probability of flooding will be more. If you have only two number of drain into your entire area, what will happen? That drain, because over flooding from the drain results into the flooding, right? Apart from that of the rainfall. So therefore, when we take road and drain intersection, indirectly we are trying to find it out how many drains are flowing from that particular area, and accordingly the rating of number of road and drain intersection per what we can say the intersection per area, that has been taken as one of the parameter. Some people take the distance from stream. This is also one of the parameter which they use for what you can say finding out the ultimately the hazard, that how much far away the distance is from the river. And there are other factors like the what you can say new thing, or it was there earlier, but now from these GAN course we learned that soil moisture is also one of the important parameter which one need to consider for analysis purpose. So one can take the sixth parameter, soil moisture, and measuring the soil moisture also you can try to find it out, flood hazard assessment. So number of factors which affect the flood hazard depending upon the availability of the data or measuring the data, you can strengthen what you can say your analysis. So not limiting yourself to these 5 parameters, you can take more parameters and can do analysis. So I have explained only 2 things up till now. Number 1, this particular table, from where it has come? It has come from the spatial analysis of the data, which I have explained you in my last lecture, right? That you have taken the DEM and process and land use land cover, you find out. You have taken the soil map and you find out the type of the soil. You have taken the drainage density, processed your DEM, and using ArcGIS tool, you work out the drainage density of the areas and rainfall of that particular area that you have collected from the rain gauge stations or nearby authority. That slope that you computed from the slope map for watershed number 1. Okay, so this particular table which I have given you as directly as a data needs lot of processing. That is a spatial analysis of various data to find out all these values, and then afterwards you can start your assessment of flood hazard. So first step is number 1, decide the area. Number 2, process your area. Number 3, prepare the what you can say watershed characteristic of the area. Then number 4, that you have to rank it or give a rating of it. Up to this, what we can say, no AHP, right? Or you wanted to apply AHP to this data, right? Up to this is your data which is required to process your AHP model. Is it clear? Hello, someone of you unmute and reply. Up to this it is clear?
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
Clear.
So now we will go for applying of AHP. So consider as sometimes it's not giving feel to us that what exactly we are doing. So therefore, I have taken this map wherein shown as this particular table which we have prepared, watershed 1, 2, 3, 4, 5. So what is there? So this is watershed 1, watershed 2, watershed 3, watershed 4, and watershed 5. So it will give you feel that for this particular basin which have number of drains, see here this drain is moving like this. Okay, in watershed 1 these drains are there which are moving like so. Now you can understand even the drainage density also. If I take watershed 3, see so many drains are there. Okay, if I take watershed 2, then this is the elongated shape of basin and which have some small dam also. So this is the watershed number 2. Okay, so we wanted to rank flood hazard for watershed 1, watershed 2, watershed 3, watershed 4, and watershed 5. Right? So this is our problem. So the first step to solve this particular problem is to go with. So this I have already explained 5. Yeah. To go with normalization of data. So this is my data. Okay. So to normalize data, right? What we have to do? What we have to do? We have done the rating here, 0 to 10. That is high hazard. High hazard, yes. Okay, 0 to 10 million. Water is high hazard, yes. Drainage density value of greater than 151 is high hazard, yes. And rainfall of higher value is high hazard, yes. 1100, right? So here low value is higher hazardous. Low value of slope is higher hazardous. So I have marked here low value of slope, higher hazardous. Okay. Then second, that is water. Water is 1. So water is high hazardous. So I gave it water as 1. Okay. Then from where the number 2 has come? Now the number 2 has come from your data. What is your data? Agriculture, then built up, then agriculture, then forest, right? So you have that this data. So based on that data, now you prepare a rating table. So that rating table is like this: 1, 2, 3, 2, 4. Similarly for soil, soil is what the values given. So clay is says 1, loamy 2, silty 3, sandy 4. So you can see here first is clay. So clay is 1. So this table is prepared. Soil, clay is 1. Watershed 2. What is the say soil? The soil is silty. So for soil, silty soil, what is the number? 3. So the 3 number is given. Okay, so like this, I give you 5 minutes. You prepare this table, step 1 table in your notebook. I am giving you 5 minutes. Please do it. Done, everyone?
Hello, sir.
Please.
Will it be okay if I do it in Excel?
Yeah, that's fine. You will
Okay, okay,
find answers fast,
okay, okay.
right? I have not insisted for Excel because many of you may not be having, or if you are working on a laptop, then you can do simultaneously on a laptop.
Oh, actually, I'm in my
That
office,
will speed up
so
the calculations. If you do it on in Excel, that will speed up your work.
sure, sir.
So everyone has to do. Please, if you have done earlier also, then also you do, so that you will have mastery on this. Everyone has to do.
Sir, we will have to just rank the individual factors according
No,
to
no.
the
First, you just write down the values, because
okay,
the table which the data which I have given has got words. So that I have converted into all numericals. So you do that. Then afterwards, I will explain what to do next. First of all, you prepare the data which is given in words. Some of the data which was given in words, that is quality data, into quantity data. And if this is done, then I am explaining further what to do.
okay, sir.
So if everyone has prepared this table with values, unmute and say yes, sir. Then I'll go ahead.
Yes, sir.
Okay. So now you can see here some of the cells I have marked orange. Okay. So how this I have marked orange? This shows the value of high hazard. So water is having high hazard, 0 to 10 slope is having high hazard. So value in that range, that I have marked with what you can say the brown color. Okay, this particular color. Then land use land cover, water is high hazard, so that I mark here 1. In soil, I think it's a clay soil which is having high hazard. Yes, and the watershed head is having a clay soil. I marked it with this color. Then drainage density when the value is greater than 0.151, so higher value, that out of all this, which one is the higher one? So this one I have marked with 0.061. Okay, and the rainfall, which one is very high? So that is 1150, that I have marked, highest value I have marked. Now you have to convert this table or this data into normalized data. So to do the normalized data, I hope all of you know that what is the meaning of normalization data. You have to convert the data between the value 0 to 1, not exceeding 1. So where other values are more than the hazardous value, in that case, the hazardous value divided by that of value of that particular cell. So suppose if you want to do normalization of slope column, then what you do here, 10 divided by 20, 10 divided by 10, 10 divided by 33, 10 divided by 54, and 10 divided by 38. Step number 2, write down in your notebook, step number 2, normalization of a matrix. So to normalize it, the cell value which is shown in this color, right, that is the lowest one. And as we need the value of normalized matrix between 0 to 1, what we will do? 10 divided by 20, 10 divided by 10, 10 divided by 33, 10 divided by 54, and 10 divided by 38. That is step 2, normalized matrix for slope. Similarly, if I go for land use land cover, so this is 1 and this is 2. So what it will be here? 1 divided by 2, 1 divided by 3, 1 divided by 2, and 1 divided by 4. Then you will get all the normalized values. Someone will say, no, sir, I will do 2 divided by 1, 3 divided by 1, 2 divided by 1, 4 divided by 1. Then those values will be more than 1. So it is not a normalized value. So whenever you wanted to do normalized value, what you have to do? If your value is less than other values, you have to divide it by other values. Okay, so that will give you a normalized matrix for normalized value for land use land cover. Similarly for soil, so 1 divided by 3, 1 divided by 4, 1 divided by 4, and 1 divided by 2. Okay, that will be for soil. Then drainage density, that is 0.061. So sal value, that is 0.061 divided by all other values. That is 0.011, 0.035 divided by sal value divided by, okay. So sal value divided by this, that will give you 0.021. Okay, rainfall, it is very easy. 1150 it is there. So here you cannot divide 1150 by 950. You have to divide 950 by 1150, 850 by 1150, 450 by 1150, 1150 by 50, and 750 by 1150. So that will give you the normalized values of rainfall. So if you have done, you will get all the values like this. And I have explained in the last row what I did. So 10 divided by sal value I did for slope, 1 divided by sal values I did for land use, 1 divided by sal values I did for soil, sal value divided by 0.68 for drainage density, and sal value divided by 1150 for rainfall. So how this I have changed? I have considered the first rating value, the highest hazardous value, right? So in some cases it is value divided by sal value, and in some cases sal value divided by the hazardous value. So it depends whether your value is higher or whether your value is lower, right? And accordingly you have prepared a normalized matrix, right? So I hope all of you have done this, prepare the normalized matrix. Hello.
Yes, sir. Sir.
Done? Let me
Yes, sir.
see, because I have another screen also, so I'll check it in the chat box how many of you have written as yes sir. 1, 2, 3. Acha, recording I missed. Oh no, it's recording is on. Hmm. So many of you have wrote done. Those who are writing done, please be careful, because last at the end of example is done, I will ask your answer to be posted in WhatsApp group. So please don't try and see me. Yes, sir. Okay. If you are doing, then only you write yes, sir. Otherwise, at the end, I may ask you to post your answer in WhatsApp group. Okay. Okay, fine. So normalization is done now. Now the next step is the comparative analysis, which we have done, that we have used the Sati scale, compare these parameters and got the final matrix. So this is the matrix which we have obtained after what? Doing AHP questionnaire survey, that what is the significance of slope with slope, slope with land use land cover, slope with soil, slope with drain density, and slope with rainfall. Okay, and according to the weight given by expert, this table has been prepared. Okay, so please note down this table, because this I have not given you as a data. This table, from where this table has come? This table has come from AHP questionnaire survey, which we have conducted. AHP questionnaire survey, which we have conducted, and the experts have given these weights. So please note down this. Done?
Yes, sir.
Okay. So once you got this, now the computation starts. So this table I have given name as table A1, right? Flood parameters of flood hazard, that is A1 table, right? So now what you have to do to find out the weight of the parameters, the first process is I'm doing it using geometric mean. So in geometric mean, what I do, all these values for slope 1, 1 by 3, 1 by 3, 1 by 5, 1 by 7, raised to, I'll multiply all these and raised to 1 upon n. What is the matrix size? 1, 2, 3, 4, and 5. So raised to 1 by 5. So here 1 into 1 by 3 into 1 by 3 into 1 by 5 into 1 by 7 raised to 1 upon n. So 1 upon 5. So this is the value. Similarly, you do for land use, land cover, for soil, drainage density, and rainfall. Please do it yourself. Next step is work out the weights by geometric methods, multiplying all the slope values raised to 1 upon n. This is called geometric mean method. There is an arithmetic mean method also. You can add all and divide by 5. That can also be a weight. And there are other methods also by which you can determine the weights. I have used geometric mean method. So slope, land use, land cover, soil, drainage density, and rainfall, and all raised to 1 by 5. Work out for all the values. Done? If you're done, then please say that you're done. Then I'll go to the next step.
Hello, sir.
Yeah,
I had one doubt in that table. This
yeah.
matrix is a skew symmetric matrix, I guess. Same.
5 by 5, na? 1, 2, 3, 4,
No,
5.
no.
5 by 5
Uh,
matrix. 1, 2, 3, 4, 5. 5 by 5.
no, the matrix is skew symmetric. So the values are the ith row and jth value is the inverse of jth row and ith value. Like if the
Is there anything? Let me check. Huh? That should be
uh,
there.
uh,
1 by 7, 7, 1 by 7, 7, 1 by 7, 7, 1 by 3, 3, and 1. It's correct. Just check here.
uh,
Slope rainfall 1 by 7. So rainfall is 7. Correct. Then
uh,
land use, land cover, and rainfall is 1 by 7. So rainfall is 7.
no,
Right.
so
Then soil and rainfall is 1 by 7. So rainfall and soil is 7. Correct.
just
And
check, sir,
drainage density
soil and
and
drainage density.
rainfall. Hello?
Just check soil and drainage density.
Soil and drainage density, soil and drainage 1/3.
And here it is
Drainage
5.
density and soil 3. Yeah, it's okay. Because the
No, sir.
experts have given,
No,
when they have
no,
compared
sir.
soil and drainage, wait. When experts have compared soil and drainage density, they have given low weight to drainage density, 1/3. So automatically the drainage, 5 will not come, it will come 3. Okay.
That's
This
what
one.
I was saying, sir.
Yeah. This is 3. This is 3. This
Because
is not 5.
I
This
was
is
working
error.
in Excel, so it was having error.
Okay. This is 3.
So
Correct.
what value should we take, sir? I
3,
have
3.
taken
1 by soil and drainage density is 1/3. So drainage density in soil is 3. Okay. Check other values also. Any another error? 1/3, 3.
So
That
tell
is
other
okay.
participants also to change the respective.
1 minute. 1 minute.
There-
I'll check. It's very easy.
Okay.
1, 3, 3, 5 and 7. Correct. Chalo. Second one dekh lete hain. Land use land cover. That is a slope and land use land cover is 1/3. So this is 3, correct. Now check this 1/3. Then this is land use land cover.
I guess other values are correct, sir.
Correct. All are correct. That may be a typo
Only
error.
this one was
Okay.
the.
So
Okay. Thank you, sir.
accordingly you change it, this 3. So I think in next table also you have to make it 3. Drainage density and soil, na? That is 3. Okay. So all values you got for this. Hello. Everyone, you got these values?
Yes, sir.
Yes, sir. Please type in chat. Yes, most of you have got it. So I'll go to the next slide where you can see A2 is your table of all these values. Hello. Whatever values you got here, na, that I wrote into table A2. That is slope, land use land cover, soil, drainage density and rainfall. Okay. Then do sum of this column. Hello. A2, the weights, do sum of these values: slope, land use land cover, soil, drainage density and rainfall. The sum will come 7.427212. Have you made the sum? Right? Now, from that, you have to make a next table for A2. How? The individual value divided by the sum. That will be the value of slope. These are my final weights. A2 matrix is for weights, and the weights which you are deriving are the slope value divided by sum, land use land cover value divided by sum, soil divided by sum, drainage density divided by sum, and rainfall divided by sum. And then you will get this A2 matrix. Now you got the weights. These are the final weights for your parameters. But the most important step is followed by this. This is the working out of the weights. This particular process we have done to find out weight of slope, land use land cover, soil, drainage density and rainfall. Acha. One more thing, that when you are doing the computation, you are a hydraulic engineer, and when you know that the hydraulic engineer or engineer should know the basics of hydrology also. Okay, hydrology and hydraulic both. So when you find out the weights, here you find out that the rainfall in terms of percentage, if I will talk, the slope have 4% weight, the land use land cover have 7.3% weight, the soil have 11% weight, the drainage density have 23% weight, and rainfall have highest 53% weight. Right? So don't simply accept the weights which you have computed. You please check also whether the computed weights are scientifically and technically correct or not, right? So in our case, we don't have any problem, but I was witnessing one presentation, and in that presentation, the student has designed storm drainage network, and in designing of the storm drainage network, he has used AHP, and in AHP, the weight of rainfall was minimum. Right now you are designing storm drainage network, and in storm drainage network, if your weights which you have worked out, which have minimum weightage for the rainfall, definitely something is wrong there, because the drainage network design itself depends upon the amount of runoff, and the amount of runoff depends upon the rainfall. So while computing also, you please check the weighted values which you have arrived are correct or not. If they are not correct, or if you feel some doubt is there, then you check the entire process back, that have you done something wrong, whether you consider some parameters wrong, whether the expert have understood the parameters, experts have misunderstood the parameters and given the weights wrong. All these possibilities are there. So like doing any modeling, in this also you need to be very, very careful, and you need to check from your knowledge what you are doing is correct or not. For example, you have done 2D modeling of rainfall runoff, and suddenly you get the depth of water at one particular place as 40 meter, other place as 60 meter, third place as 80 meter. What will happen? Right? And you go and show those results to what you can say the consultant or any authority. What he will say? He'll say that something is wrong in your model and you are not fit for carrying out this modeling, because 40 meter depth, unless and otherwise there is a breach of dam, unless and otherwise there is a breach of again large dam, and there is a vast difference of level of elevation at a dam and that of the place where you are coming across this much of depth of water, then only it is possible. Otherwise, this much depth of water is not possible. So simultaneously, you have to check your results with the field condition also, that the results which you have derived are really practically possible or not. So you got now A2 matrix, everyone? Hello, someone of you say yes, sir. Last I saw that she wrote at 5:42 p.m. After that, anybody has wrote? Yes, let me scroll down. Okay, yeah, so many are writing now. Fine, chalo. That's good. So these are my weights, but these weights are correct or not. So there are two things. Once when I am checking the consistency, it will give me the computational check. But the weight checks, that what I have explained you right now from hydrology and hydraulics point of view, as an hydraulic engineer, that you have to check, right? Because even if with the rainfall weight very less, if your computations are correct, the consistency ratio may be less than 10%. But it is not correct actually if the rainfall weight is less in case of flood hazard, if the rainfall rate is less in case of what you can say stormwater distribution network or stormwater design, right? So that you have to check. I have also seen, I have come across one of the funny incident where in the rainfall runoff modeling was done using ANN. They have taken number of parameters, the values were not matching, and the student have removed the rainfall from the input parameters, right? So this should not happen, because we become so mechanical when we are deriving our model or doing the calculations, and become so desperate that you need results anyway, but you don't know that by trying to get the results, right, you should check the correctness of your model also. So the next step is multiplication of two matrix. That is matrix A1, which are your the weights which are given by expert, and A2, the final weights which you have which we have worked out. So what do you do? 1 into the respective weight of that. So this is the slope weight, this is the land use weight, this is the, I'll use the pointer so you will come across. This is slope weight, this is land use weight, this is the soil weight, this is the drainage weight, and this is rainfall weight. So what do you do? 1 into the weight of that parameter, 1/3 into weight of land use, 1/3 into weight of soil, 1/5 into weight of drainage density, and 1/7 into the weight of what you can say rainfall. And by doing that and summing up, you will get the value 0.228202 for slope. Like that, you work out for land use land cover, work out for soil, work out for drainage density, and work out for rainfall. Please do it yourself. Multiplication of two matrices A1 and A2. Done. Product of matrix A1 and A2. Nilesh and Palvi wrote that they have done. Others? So I can see few more answers in the chat box. So you will have this A3 matrix as 0.228202, 393,102, 6514344, 1.184829, 2.839828. Right? This is my A3. Now from A3 you have to prepare A4 matrix. And what is that A4 matrix? Values of A3 divided by your weights A2. Values of A3 divided by A2. A2 is what? Your weights. So divide the values of A3 by A2 and you will get the vector matrix A4. So the A4 values are here. After A3, go for matrix A4. After A3, go for matrix A4. Done. So once you got the A4, sum of the A4, that will give you the sum. Okay. From this sum, you can find lambda max is equal to sum of matrix A4 divided by n. So what is my n? N is my matrix size. So lambda max value is equal to sum of A4 divided by 5. So that will give you lambda max as 5.305034 divided by n. N is what? N is my matrix size. That is n is 5. From that, you have to work out consistency index. The consistency index, the formula is lambda max minus 5 minus m divided by m minus 1, where m is my matrix size. The matrix size is 5 by 5. Please do up to CI and type in chat box, done sir. Now consistency ratio is okay.
Hello, sir.
Yeah.
There was network issue, so could you please repeat the steps after the A1 into A2 matrix?
Up to what you have done? A3 you have done?
Yeah, I got the values of A3.
A1 and A2, A3 you got, na?
Yes, sir. Yes, sir.
Okay, so now A4 matrix. In A4 matrix, values of A3 divided by values of A2 means your weights. Divide all the values of A3 by values of your weights, that is A2. And whatever you will get, that is your A4 matrix. If you are doing in Excel, you can do it fast. Simply you have to write formulas there.
Okay, sir. Done, sir.
Done, na? Then sum it. A4 matrix, you sum it. So summation of A4 matrix is 26.52517. Now you have to work out lambda max. So lambda max is sum of A4 matrix divided by m. M is your matrix size. So lambda max is equal to sum A4 divided by 5. So that will give you lambda max is equal to this value. From that, you have to find out consistency index. And the formula for consistency index is lambda max minus m divided by m minus 1. Consistency index lambda max minus m divided by m minus 1. M is my matrix size. Done up to this, everyone? Yes, it is correct, Palvi. 0.07625, correct. Okay, so many of you have done. Okay, now we want to work out consistency ratio. So consistency ratio is consistency index divided by randomness index. What is this randomness index? Ri. This randomness index Ri is given by Sati for various size of matrices. If the matrix is of 3 by 3 size, the value of Ri is 0.52. If matrix is of 4 size, value of Ri is 0.89. Our matrix is 5 by 5 size. So we'll take 5. For that, the value is 1.11. So CI value divided by 1.11, which comes out to be 0.06, which is less than 10%. That is less than 0.1, that is 10%. It comes out to be 6.8%. So 0.1 or 10%. So our weights are acceptable. As the consistency ratio is less than 10%, the weights are derived in which table? Hello? Weights are derived in which table?
A2.
A2. So A2 are your final weights. Remember, this is for consistency check, that whether the derived weights are correct or not. To check that the step 4 and step 5 has been carried out. A2. So, yeah. You are not audible. Okay, so now we will go for ranking of watershed. In that, what you have to do? B1 into A2. B1 into A2. What is your B1? 0.5. That is 0.5 is this table. This one is your B1, normalized matrix. Right here. B1 into A2. What is your A2? A2 are your weights. This is A2. Hello. So you have to multiply these two tables. You have to multiply the normalized matrix and your weights. So 0.5 into your weight for A2 is how much? 0.04261. One I have done. I will show that. I'll keep that slide. Yeah. So for watershed 1, I did it 0.5 into its weight, 1 into its weight, 1 into weight, 0.18 into weight. Like that you have to do for all. That is your rank. So watershed 1, watershed 2, watershed 3, watershed 4, and watershed 5. This is known as a rank mark, or it is also known as score. Rank is equal to B1 into A2. Rank is equal to B1 into A2. This is called rank mark, or this is called score. This is called rank mark or score. And based on your score, you have to rank the watershed. So watershed 4 at the highest risk, highest having highest hazard, then comes 0.84, then come 0.69, then 0.64, then 0.51, and 0.43. So the rank are 4, watershed 4, 1, 2, 5, and 3. So high hazard 4 number, then 1 number, then 2 number, then 5 number, and then 3 number. Rank or score. Ragvi G wrote, done, sir. Was it old message or new message? I don't know. I think it's a new message. Those who have worked out till rank, please type in chat box whether you have done it or not. Up to rank is over. Are you getting the same rank as in the slide? Yes,
No, sir.
Jignesh?
Rank is different, sir.
So there will be a few difference will be small, not large. What you are getting? Values you are getting wrong? Score you are getting wrong? Hello? Yes. Yes, I will see. Watershed 4 is at high hazard. B1 into A2 you will do, you will get this answer. Oh, that's great. I got the confirmation that some of you are getting the same values as what I have worked out in this example. Shall I go ahead? Because I need 10 more minutes after this also. Please tell me. Okay, so you can see here, these are all watershed numbers. So you can say that watershed 4 is at the high risk. So you can see. Now, the another important point is whatever answer this has given, AHP model has given, you need to check that also, that will it really be possible that watershed 4 at maybe the highest risk? Yes, you can see all the drains are draining down, and in watershed 4 the water bodies and drains their magnitude seems to be more, right? And as the flow is from top to bottom, definitely the watershed 4 may be at higher risk, right? Similarly, the next is, I think, watershed 1. The width of the distance from the river is very less. It is a elongated shape, and hence it is having high hazard for the flood. Okay, and the minimum you will see, that is third one. So you can check here in third, you have all small drains, right, and which are draining down. Okay, so this also you have to check along with what you can say the answer which you have got by AHP ranking, right? So after doing this, the watershed and all ranking that we have done manually, okay, I'll show you that you can do it using software also, right? But up to weights. Okay, so this is the software you can see on the screen. This is summary, what it says: input, the input parameters, multiple inputs, then 3 by 3 matrix input you have to view here, 4 by 4 in this matrix, 5 by 5 in this matrix, 6 by 6 in this matrix, 7 by 7 this matrix, and 8 by 8 this matrix. So AHP is used, or AHP is good up to 8 by 8 matrix, right? It can be used for more than 3 parameters, and it can be used for maximum 8 parameters. Okay, so our matrix is 5 by 5. So I don't have these values of experts. Can anybody detect me? 1, yes, Vignesh, you detect the values which is given by the expert, weights. 1, then next. Vignesh, are you there? I think he's not there. Anybody else? Because I have to open the other one.
One.
File.
1
then
by 3.
next. First line.
First row. 1 by 3.
1 by 3.
1 by 3.
Okay. Again 1 by 3.
Yes, sir.
Okay.
Then next is 1 by 5.
1 by 5.
Next is
yes.
1 by 7.
1 by 7. Okay. Now second row.
Second row, first column 3.
Yeah.
Next 1.
Yeah.
Next 1 by 3.
1 by 3. Yeah.
Next 1 by 3.
1 by 3.
Last one is 1 by 7.
1 by 7. Okay. Next.
Third row, first column 3.
Yes.
Next 3.
Yes.
1.
Yes.
Next 1 by 3.
1 by 3. Yes.
Next 1 by 7.
1 by 7. Okay. Okay. Next column. Next row.
Fourth row, first column 5. Next is 3. Next is 3. Next is 1. Last one is 1 by 3.
1 by 3. Okay. Last row.
Last row 7. Next is 7. Next is 7. After that 3. 1.
1. Just check you got the values. Here, normalized weight. Can you see where my crusher is moving? Normalized principal vector after first iteration, this much percent. After sixth iteration, 6%, 8%, 9%, 21%, and 56%. These are your weights. And the consistency ratio is also given here, which is marked in green, 8.1%. And the principal eigen CI, consistency index, is 0.091. And principal eigen vector, that is lambda max, 5.363. Right? So in 1 minute, the entire process which you have done, you got the answer for the same. So these are your final metrics. matrix, right? So this is AHP software. I'll share this also with you in your Google Classroom, right? So even if you have a 7x7 matrix computation, 6x6 or 8x8, right? You can save your time and you can compute it directly putting into A, the weights of the, right? Scoring we have not done. You remember which step we have not done? B1 into A1. That is multiplying your normalized matrix with that of your B1 into A2. Normalized matrix with the weights which you have derived finally. When you will do that, then you will get ranking. So what you are getting here, A2 means from here to here, the entire process which we have done, right? These values which you have given, and I think from this, not from this, the table of experts weight, even from this. So step 3, then step 4, and step 5. Okay, even step 6. This is directly computed using software. 4, 5, and 6 steps that is computed directly using the software Excel sheet. Okay, so this way you can work out the weight using AHP. So if you have any question, I'll just try to answer your doubt. Yes, any question? Anyone have any doubt or any question for whatever I have taught up till now? So if you have no question, Rasmi, can we go for attendance? Rashmi, are you there?
Yes, sir.
You are not audible, Rashmi. Or have I?
I request everyone to
sorry.
switch on their cameras for attendance.
Yes. Okay. Marut, you please explain after the attendance that which material we are going to provide by post to the participants. Marut, after the attendance is over, please inform participants which material we are going to provide them by post.
Okay, sir.